Dear all, welcome to Civil Services with ZAKI. First of all, Happy Independence Day and very wishes to the Azadi Ka Amrit Mahotsav. As you know, we proud to be an Indian. Why? Because our nation is the land of Gandhi, land of Buddha, land of peace and land of prosperity. So let's together unite and celebrate Azadi Ka Amrit Mahotsav. So now we go to forward, and today's topic is what is the air pressure, and basically, as you know, it is related to the major geographical concept series. So let's move forward and see what is air pressure. So if you see the pressure of gases within the atmosphere, basically these gases are highly variable both vertically and laterally. So these variation in the pressure define the structure of the atmosphere and also determine the nature and direction of the atmospheric motions. So basically, if you see your weather pattern, weather phenomenon, it is directly related to the atmospheric circulation and atmospheric motion. So that's why air pressure is a very important topic in the geography, basically in the climatology. So if one place in the atmosphere has higher pressure than the another place, this imbalance of pressure causes the airflow. So airflow, that's why air and wind. Airflow called wind. So basic difference between the air and wind. Air present everywhere, but wind is the motion of the air due to the pressure gradient. So what is pressure gradient? So let's move and understand. So how do we describe the measure pressure, and how do we use these measurements to understand or even predict the flow of the air? It means, you know, wind. So flow of the air means wind. So wind play an important role in our atmospheric circulating system. So let's move forward and see what is pressure. So first of all, we know what is pressure. As you studied various physics and other science book about the air pressure. So what is pressure? So if you see here, pressure is an expression of the force exerted by an area. So if we exerted certain force with an area, it's called pressure. So usually it's from all direction. In the case of gases, because we study here gas, so gases, pressure is related to the frequency of molecular collision. So it is the collision of air molecule as freely moving gas molecules collide with the other object, such as the walls of container. If we put some container and use some air molecules, they collide with their wall and create a pressure. So that's why if you see such collision that keep balloons, soccer balls and bicycle tire inflated. So we understand about the what type of the pressure exerted and what are the role of the heat and basically energy in the decrease or increase the pressure. So let's move forward and see this picture. So it is a container filled by gas, and it is the molecules of the certain gas. So if you see here, molecules of the gas is sealed glass container move rapidly in the random direction. So see here, random directions, and some strike the wall of the container. So strike wall of the container, such type of this molecule and this molecule. So the force imparted by these collision is pressure. So what is pressure? The force. This force imparted by these wall is called pressure. So the more collision, it means 1, 2, 3. It's more collision, more pressure. So more collision, collision, there are the more pressure exerted on the wall of the container. Such type of, if you see some wall, if you one person push the wall, it is low pressure. If 3% or 4% or 5% push, it means more pressure. So pressure increases when the molecular collision increases. So here, if you see here, so we move forward and see if we pull or press these pressures. So if here you see, if push down the lid of the container, so such type of the container, we push the lid of the container, it means the volume of the gas decreases. So same number, but the molecules are the same number, molecule confined into the smaller place. So it is certain smaller place, not the whole glass container. So the lower parts of the container walls are now struck by greater number of molecule closely, more closely packed gas molecules. So if here you see gas molecules, more compact. So the pressure is greater. So here pressure is increased, pressure is greater. So decreasing the volume of a gas, increasing its pressure. So if we decrease the volume of the gas, it means, so it's consistent with the Boyle's law, as you know and read in the chemistry. So that's it is the Boyle's law. So we move forward and see what are these applications of the atmospheric circulation on our weather system. So if we see here, if we assume certain container and if we put on weight, so what happens if put a weight on the top of the container and either cool or heat? So we put weight and then heat or cool. So what happens? These types. So what is the impact of the thermal? Basically, as you know, our atmospheric circulation is basically based due to the thermal circulation. So see here, if we cool the container, putting ice, by placing in ice, the molecules become less energetic. So here heat is reduced, means energy is reduced. So they strike the wall and the lid of the container, less often the gas pressure decreases and lid move down. So energy decreases, molecule more closely packed, and then the volume of the container decreases and the lid move down. So lid move from here to here, down, from here to here, it's down. But if change the scenario, see here, instead of cooling, we heat the container. So here see, if we instead heat the container, the gas molecules become more energetic. So here energy is received by these gas molecules. So the gas molecules become more energetic and strike more wall and the lids of the container. And consider more often gas pressure is increased and lift the lid. So here gas pressure is increased and lift increases, the high lift. So increases and lift the lid. So lid. So that's similar role play in our atmosphere due to the pressure gradient, due to the thermal differentiations between the various places of the earth, because all the places of the earth receive not the similar insolation. So what is insolation? As you see my previous video, detail about the insulation. So we move forward and see the pressure. If we force it, so pressure is equal to force into area. Force exerted certain area and it is called pressure. So what is force? According to the Newton, force is the product of the mass and the acceleration. Mass, if means kg, acceleration means meter per second, and area is meter square. So kilogram meter per second. Kilogram is mass, acceleration is meter per second, and area is meter square. So it is called kilogram meter per second is called Newton. So it is called Newton, and area here meter square, so meter square, Newton by meter. So Newton by meter, it is called pascals. So pascals is the unit of pressure. So but the pascal unit but the pascal unit is not commonly used by the scientist and the climatologist, because it is in one unit. If we see here, 100 pascal equal to 1 millibar. So basically millibar is used by the atmospheric circulation scientist, atmospheric scientist all over the world. So if you see here pascal, 100 pascals is equal to 1 millibar. So as you know, the pressure of our earth is 1000 millibar, approx 1000 millibar near the sea level, decreases after you go to the above. So 100 pascal equal to 1 millibar. So here is the pressure. So pressure's unit of the pressure. So now we move forward and see the role of this pressure. So what causes air to move? So these pressure played a great role in atmospheric circulation. So basically they are the basic factor, and these pressure gradient move the wind. So see here, air move because there was a variation in the air pressure, and such pressure density variation are mostly caused by the differential heating of the air. Differential heating because due to difference insolation. So as you know, the insolations are all over the world are not same, more in equator, less near the pole. So and by the air or by the air current conversion. So air current, if you see the wind move due to the pressure gradient, it is two types, wind and air current. What is difference between the wind and air current? If you see the wind is, if you see, if the air flow horizontally, if you see air flow horizontally, it is called wind. If air flow vertically, like lower to upward, or this type. So if air flow vertically, it is called air current. So due to by air current, air current either converge or diverge. It means they go up or they sink down. So the atmosphere is not closed container, as we earlier discussed about the container, but atmosphere on earth are not so type of the closed container. So the changes in volume that is being compressed or expressed come into play, and these volume change can make a pile or spread out the resulting variation in the air pressure. So see how they create also. So see here is the high pressure area. If you see here, high pressure area, and here is low pressure area. Low pressure 996 millibar, and it is 1008 millibar, and it is isobars. Same pressure area are called isobar lines. So if you want to know more about what is isobar, isotherm, etc., then you must join our foundation batch. And as you know, our foundation batch soon start on 22nd August 2020 in Sub IAS Academy. So you can join, because this is very significant foundation batch, and it is related to the Jamia and Jamia Nagar. And as you know, it is because this is very significant, because this is limited seat. So only 60 students are, only 60 seats are here. So don't forget to subscribe my channel also, and if you want to know more about what is climatology and what is the all weather phenomenon and etc, and what are the currently happening around the globe, which is very significant for the civil services examination, then you must join this our foundation. So let's move forward and see. The movement of air occurs due to equalize the difference of the air pressure between the adjacent area, a pressure gradient. So as you know, that is a pressure gradient. So air move from high pressure to the low pressure. Air molecule in high pressure zones are packed more closely together than the low pressure zone. So the molecules in the high pressure zone tend to spread out towards the low pressure zone. So see here. So another thing, the converging air or diverging air, it is, as you as earlier I told you, that it is basically played a great role in our atmospheric circulation, and these are called air current. So see here, high pressure zone and low pressure zones can be formed by the atmospheric current. So it is called air current or atmospheric current. Air currents or atmospheric current that converge or diverge. So converging air current compress the more air into the smaller place. So see here, conserving air, they compress more air molecules here and compress more smaller place, increasing the air pressure. So here pressure is increased, so it means it create high pressure zone. So diverging air current move air away from the area. So if we see diverging air, it's move away from the area and lowering the pressure. So here molecules are less and the pressure are low. So here high pressure, here low pressure zone. So causing low pressure zone, forces associated. So forces associated with converging or diverging force called dynamic forcing. So it is called dynamic forcing. See, so dynamic forcing played a very role in our atmospheric circulation, whether it is monsoon, whether it is other weather phenomenon. So we move forward and see another thing. Another thing is, if you see the various pressure belt across the globe. So see here, most variation in air pressure and most wind, however, are caused by thermal effect. As we know, the insolations are different from the different places of the globe. So specifically differences in insolation from place to place. The cross section you see here, it is a cross section of a certain place. So cross section, so a high pressure zone caused by the sinking of the cold air. So if you see here, it is cold area, and if you see here, air pressure are less, because as you go, the higher air pressure is less. So and these air, as you know, the most of the weather phenomenon related to the troposphere and confined with the boundary. This boundary is called tropopause. So it is tropopause. So here is a cooler place, cold, and here is the warmer place, warm place. So if we see cooler place, the molecules are stick together, close together. So the section show the cold high altitude air towards the surface, the adjacent pressure of the low zone. So warmer near the surface temperature, if you see here, it is the warmer areas. So the cooler place conserving the air. So here air is sink down towards these cooler area and it create a high pressure zone. So if we see the warmer area create low pressure zone. So warmer area near surface temperature have caused air to expand, and air expand and go to the upper and become less dense and rise and causing low pressure zone. So these are because as you know, the colder air not override the warmer air. Warmer air is less dense and less lighter than the colder air. So after troposphere, above the troposphere, it is the warmer place. So that's why the colder area create high pressure and the warmer area create low pressure. So we will study in detail in the atmospheric circulation and what is the impact of these circulations of the Coriolis forces. So as you know, our next video on the Coriolis force. So if you want to know about what is Coriolis force and how Coriolis force play a great role in the cyclone creation and etc., then you must subscribe our channel. If you are new, then subscribe my channel and tell your friends and colleagues about our initiations. So that's all about the pressure gradient and the measurement of the pressure. So once again, happy Independence Day to all of you, and don't forget to subscribe my channel. My subscription speed is very slow, so as you see. So thanks for watching this video. Thanks a lot. We will meet again in the next week with the next video. Thanks a lot.